This is BSA by Design, a podcast about transforming healthcare, educational, and research facilities through expert design and insight. I'm your host, Brian Moore, and thanks for joining us again. In this episode, I'm joined by Troy Dyce, Evan Steckler, and Luke Richter to talk about mechanical engineering and about the benefits or potential drawbacks of bringing in 100% outside air. Before we get to our conversation, let me introduce our guests. Evan Steckler is a mechanical engineer with BSA and located in our Denver studio. He is a licensed PE and graduated from Kansas State University with a Bachelor of Science in Architectural Engineering, and previously worked for WSP before joining BSA in early 2022. Troy Dyce is a Senior Mechanical Engineer 2 and Engineering Lead with BSA and located in our Tampa studio. He has 20 years of experience. Troy graduated from the University of South Florida with a Bachelor of Applied Science in Mechanical Engineering, and he previously worked for Carastro & Associates prior to BSA acquiring Carastro in May of 2023. Luke Richter is a Mechanical Engineer and Engineering Lead with BSA and located in our Indianapolis studio. Luke graduated from Purdue University with a Bachelor of Science in Mechanical Engineering and is a licensed PE with the state of Indiana and the state of Ohio. Luke has his Green Business Certification and previously worked for HEPE before joining BSA in 2022. Welcome to the show, gentlemen. Thank you for joining me. You guys all, I know, are subscribers and diehard listeners of the show. And if you are, then you know I like to ask the first question to kind of warm everybody up and find out what got you interested in your career choice. So, Evan, let's start with you. How about you tell us how you got into engineering?
Yeah, so when I was a kid, my answer to the question, what do you want to be when you grow up, was always that I wanted to be an architect, which if any of our BSA architects are listening, they're like, oh, you dodged a bullet there. But then as I got older, I became more interested in math and science and realized that I was pretty terrible at anything that involved much aesthetic creativity, and discovered this a major called architectural engineering, which really focuses on building systems, HVAC, electrical, plumbing, or structural. I went to school for that at Kansas State, and I've kind of been on that track since junior year of high school, and here I am.
Troy, let's go to you.
I had no clue what I wanted to do growing up, honestly. But I was a hands-on guy. My dad did a lot of stuff around the house. We had dirt bikes, so I helped get all those ready and prepared for having fun and stuff, and then high school, kind of still no clue. Senior year, I was taking calc because I was kind of always just pretty good at math, and it's this dumb. I mean, I went to my career day and, the lady says, what do you want to do? I said, I don't know. What are you good at? I'm good at calculus. Cool. You should be an engineer. So I came home that day apparently and told my dad, that's, hey, that sounds cool. I want to try this. I don't remember, but apparently he told me, okay. Apparently he wasn't very supportive or he didn't think I could do it, but it worked out. USF had a good program nearby.
I was just going to make a joke. I'm in my mid-40s and I'm not sure what I'm doing yet either. So I like that story. Luke, how about you?
Yeah, so I'm actually a fourth generation engineer where my great-grandpa, grandpa, and my dad were all civil engineers, either working on roads, bridges, or just kind of structural stuff. So their main focus in their engineering work was making sure things didn't move. And if they did, things were a problem. But I had a little bit more of a fascination with things that moved and changed, starting with roller coasters, honestly. So had the knack for it, had the temperament for it, and chose mechanical as my major of choice.
Okay, so now 2 follow-up questions. How come you didn't go into amusement park rides then? And did you feel pressure growing up to carry on the engineering legacy?
I mean, there was a little bit of that, but my dad has a funnier story about that, where my grandma was, whispering to him in the cradle, that he's going to go to Purdue and be an engineer. But I didn't have that level of indoctrination on my part. But As far as roller coaster design, man, sometimes you just like to enjoy things and not ruin them with work.
I wanted to cover a really specific topic on this episode, and I've heard that the 3 of you would be great to talk to about it. It's 100% outside air, and really dive into the benefits and drawbacks of using building ventilation specifically with our healing market. So let's start here. What is 100% outside air mean in the context of building ventilation?
I mean, 100% outside air just means no return, right? You're bringing in 100% of your air, cooling it to what your building needs and then delivering it to space. It means dollars as far as Tampa goes. Really expensive
we'll get to that
type
too, yeah.
of design.
Evan, what are some of the primary benefits of using 100% outside air in medical buildings and hospitals?
Yeah, so there's actually a little bit of a history here on this question. As an industry, we have a totally justified, I think, tendency to err strongly on the side of caution whenever we're designing like patient care spaces. And what this really looked like as modern HVAC systems were being developed was the thought process was, let's provide 100% outside air to most critical care spaces, especially spaces like operating rooms. Let's not recirculate any air at all to these spaces. And that would seem to be the lowest risk, right? Because outdoor air, generally speaking, contains very few pathogens, volatile organic compounds compared to what we might see indoors, where sick people are breathing and furniture and paint are off-gassing and all these things. And so when you've got someone opened up on the operating table, it seems to make sense not to expose their insides to recirculated air and perhaps not to expose others to air that has come into contact with people's insides. That was kind of the initial thinking in the industry. And so almost everything was 100% outside air initially. But then because of what Troy mentioned with the dollars, which I'm sure we'll get into more later, there were some studies done in the 80s, particularly in the context of the energy crisis, and determined that a vast majority of spaces could actually tolerate partial recirculation of the air. And so there are some benefits, and then the drawbacks have kind of driven the industry away from that over the course of the years, which again, the pandemic may have affected some of that conversation, which I'm sure we'll get into. But the main benefits, outside air is in most cases cleaner than what you would have if you just were constantly recirculating.
And that leads me to, you started to mention Florida. Troy, you mentioned it before too. I'm gonna ask the next couple questions around climate, and that's part of the reason I brought you all three. We've got three kind of different. We've got Midwest, Mountain West, and Southeast. Troy, you're in the Florida environment. What are some of the drawbacks into bringing 100% outside air in that climate? And is it common or not common to try to do that?
Yeah, the additional capacity needed to accommodate the 100% outside air versus in healthcare, a lot of these systems are 20 to 30%. It's in the neighborhood of twice as far as energy costs. You're going to get like 275, 300 CFM per ton, but you're going to get like 130, 140 CFM per ton when you're like 100% outside air. So it's a lot more energy. Cost of preheat for winter operation, which you guys have. We rarely do any preheat, so that's another cost you would have 100% outside air. ERVs are great for energy savings, but a lot of the facilities guys down here just don't want to maintain them. There's ways around providing them in the energy code, exceptions and such, which, you know, in your climates that we're talking about here, I would say ERVs all day, every day, and a lot of economizer mode. We just do very, very little of that because of the first cost and the maintenance that the facility guys just don't even want to deal with. And obviously, the more outside air you have, the more exhaust you have. So it's first class for bigger ductwork, bigger exhaust fans, all that kind of fun stuff. So that's basically for Florida.
I'm obviously, and I say this all the time, I'm not an expert. I'm just a host that's trying to get expertise and thought leadership from all of you. So you mentioned in cooler climates that they need to kind of preheat it, right? Do you guys in Florida have to cool it at all, especially in the middle of the summer? How does that work?
Yeah, so 100% outside air, I mean, you're taking all the air from outside and you're cooling it. So depending on what you're serving, you know, you're going to cool it down to a certain temperature. I mean, 100% outside air, you're not seeing an SPD, you're not seeing ORs, you're seeing more, you know, potentially pharmacies.
Okay.
It's very minor applications where it's really a 100% outside air. But yeah, it's a lot more money to do that
right
in Florida just because of the climate we have.
So I'll turn to Evan, you and Luke, and I'd like to hear about some of those challenges a little bit more respective to, you know, more moderate to colder temperatures, especially in the winter. So what's Denver and Indianapolis look like respectively for you guys?
Yeah, so we have 4 seasons in Denver, but what makes Denver and other places in the Mountain West different from the Midwest, and certainly very different from Florida, is that it's very dry here. Which, I mean, it's dry in the winter in the Midwest, but year round it's really dry here. And so that presents, I think, both challenges and opportunities when it comes to treating outdoor air, whether it's 100% outside air or 30 or 40, whatever it is. And so we're all familiar with what happens to our bodies when we're in a very dry environment. Skin dries out, your nose and throat can become inflamed. It's a pretty unpleasant experience. So what also happens is that when we sneeze and cough, we expel potentially virus-laden water droplets into the air. And so in a drier environment, these water droplets evaporate more rapidly. They become smaller and actually more likely to float around in the air for longer rather than sort of dropping down onto a surface. So lower humidity can increase the airborne transmission of viruses. And so in all critical care spaces and in some other areas as well, we need to maintain at least 30% relative humidity year round. And so when you're bringing in 100% outdoor air and it's really dry air, that introduces a significant challenge to get that and can potentially impose a large energy penalty to get that relative humidity you need. Static electricity can also be an issue. X-ray image quality is affected by low humidity and static electricity. And so that's one of the challenges. You've got to boil a lot of water using natural gas or electricity in most cases for humidification, which is pretty inefficient. But there's also an opportunity, I think, in Denver for 100% outside air systems because a vast majority of the year, because it's so dry, no dehumidification is required to meet the temperature and humidity requirements of most critical care spaces. Down in Florida, all of Troy's cooling coils are constantly condensing a lot of water out of the air, and that's being drained away because a lot of dehumidification is required and is occurring. But here, even in the heat of the summer, a lot of our cooling coils don't have any condensate coming off of them because the air is so dry. And so we can usually tolerate adding moisture into the building, even on those warmer days. And so particularly for 100% outside air systems, when we have to do that, sometimes in maybe in like a hospital laboratory application, some of these other applications where it's required, it's possible to use evaporative cooling, either indirect or direct. And this is where we introduce moisture into the airstream, allow it to evaporate, and that cools the air using the same principles that work when we sweat, right, to reject heat from our bodies. And so it adds moisture, but when you're in a dry climate like Denver, you can tolerate that, and you get a really significant energy savings on the cooling side compared to like a refrigerant-based cooling system. So
Wow.
There's some challenges and some opportunities for 100% outside air, or just high outside air percentage systems in Denver.
Luke, how about in Indy?
Yeah, so I would characterize the Midwest as kind of either the best or the worst of both worlds, depending on how you look at it, because kind of like Evan alluded to, in the wintertime, we get the really cold temperatures and the really dry climate. And in the summertime, we get the swampiness that Troy experiences down in Florida. So actually, if we have a system where we're trying to introduce 100% outdoor air into, let's say hospital spaces, critical care spaces year round, then we'll have to set up infrastructure in the HVAC systems to both be able to humidify that air in the wintertime and also heat it. And then in the summertime, we'll have to introduce systems that will, wring out some of that moisture in the air and cool it down. So it does mean it can be a more careful look at the infrastructure involved in a building, particularly at the planning stage. If we're building a new hospital, to make sure that we have that humidification capability and that dehumidification capability. And, with all this stuff, kind of have to remember what the end goal is, which Evan explained earlier, of trying to make sure that the space is as clean and as conducive to healing as possible. So there are trade-offs, right? So the increased energy penalty with doing these things, some of our healthcare clients, actually a lot of our healthcare clients, consider it to be a value add as opposed to, just energy penalty. So, it's a matter of trade-offs and what's most important to you as a facility.
And Luke, I'm going to stay with you. Evan mentioned the key word when you sneeze or something, there's droplets. I think that all became vernacular no matter what your industry was during the COVID-19 pandemic. And I'm curious how the pandemic changed the conversation around ventilation in healthcare facilities. What did you notice?
Yeah, so this is an interesting question because it brings back some memories of that time. I'll say that a lot of the time in the HVAC design world, we tend to stay in the background of things, and we like to not be noticed as much. But when the pandemic and the COVID-19 pandemic came around, all of a sudden our world became kind of center stage in a lot of, especially hospital institutions' mind about, what are the risk factors in our hospital for spreading COVID-19 within our facility. And from an outside air perspective, the obvious first thing that people looked at is, well, let's make sure that the air that we're introducing into the building has the least likelihood possible of taking COVID-19 virus that's in one room and accidentally recirculating it into another room. The challenge, though, and we dealt with this a lot with a lot of our clients, a lot of our healthcare institutions, is not only do we have to do all these things and cool down the hotter air in the summer or the warm up the colder air in the winter, 95 degrees and like minus 10 degrees, for example. We're trying to do that in existing facilities that maybe they didn't have their HVAC infrastructure initially designed or sized to do those things. So there were a lot of interesting and unique engineering challenges that we ran across, which is we have a hospital and it was not designed to, introduce 100% outdoor air and yet maintain the correct space conditions for comfort and for patient care. But we need to have those types of systems for, this pandemic, because especially early on, people didn't really know what to expect in terms of volume of people that would be coming into hospitals. It was the Wild West there for a little bit. So there were a lot of challenges and honestly engineering opportunities for creative solutions to work within the constraints that we had to create environments that were introducing outside air and maintaining sort of patient safety at the same time. So a lot of a word that became kind of common parlance in that time was pandemic mode, which is taking a large air handling system to like something in your house like a furnace, but on steroids. And during a certain amount of time, let's say that an emergency department had a short period of time where there were a lot of COVID-19 patients that all came in at once. Can we modify that air handling unit for a short period of time to be able to deliver 100% outside air when we wanted to by pressing a button or changing the control system a little bit? And then kind of as a kind of point of use, we need to turn this thing into pandemic mode. So we're going to introduce all this outside air at a given time. A lot of unique projects that we worked on to try to make that a reality for our healthcare clients.
They literally wanted to flip a switch and be able to do it, right?
Yes.
How does the use of 100% outside air impact the spread of airborne pathogens beyond just COVID-19?
What I would say to that is that COVID-19 turned out to be a fairly standard, standard kind of a pathogen virus in terms of its size. That it is a virus and a particle that can be collected in filtration systems that are fairly typical to hospitals, which turned out to be a good thing. However, there are pathogens and diseases out there that present themselves as extremely small enough that they can get through typical filtration systems. Tuberculosis is one that comes to mind that really do require an enhanced level of filtration. And it would be wise to consider those things when thinking of initial planning of a hospital. Is what types of patients, what types of patient care, what types of diseases are we trying to mitigate or try to treat or try to have certain patients come to our hospital to have care done. So they're having outside air introduced into a building at a high percentage or 100% outside air can actually mitigate against pretty much anything that you can think of in terms of diseases in a hospital space that you wouldn't want to research from one room to another.
100% outside air means everything going in goes out, right? So you're not like Luke said, you're not recirculating anything, but really it's, your air change rate is as fast as it can be because you're not reintroducing anything else. So that's the best way to pull everything out, as putting everything new in from the outdoor, nothing recirc, right? So at the end of the day, beyond additional filtration, that's really the most you can do.
And Troy, you started to touch on this, I believe, earlier in the conversation. How does the use of outside air impact energy consumption and efficiency?
Well, like we said, with energy impact, it's just my chillers are running a lot harder because I got to deliver a lot more water to my air handlers to get me down to where I need to be, whether it's ORs, pharmacies, anything it is. When I've got, I don't know what you guys design middle of summer for design day, but we're 95, 80. And sometimes it's even worse than that. So it can be middle of summer, cloudy, I'm at part load or whatever it is. And then I rain and the sun comes out in 5 minutes. And
Right.
my outlet air intake is on a roof. So now it's like 100 plus degrees and like very, very high RH right there at my intake. So, design day at 95, 80, it may be worse than that sometimes, but especially on high outside air percentage units, it's just a lot of energy to get all that down. It wrings a lot of water out of your system, a lot of energy.
So I would add to that and say it does present itself as an opportunity from an engineering standpoint, where if we're recirculating air, let's say we're trying to cool air from 70 degrees, which is a internal temperature, down to say 55. If you're bringing in outside air at 95 degrees, that's just a large differential to bring it down. And if we just try and do that as just a raw cooling, just from 95 to 55, it's going to be way more energy. However, there are strategies that we have on the engineering side from an equipment standpoint. Troy mentioned ERVs or energy recovery ventilators, where we can actually use mechanical pieces of equipment to extract some of the energy from the exhaust air and basically bake it so that less energy is required to cool down the air in a cooling situation. So that's another piece of equipment. It's another first cost that's required for the infrastructure of a building. But over time, you'll notice that there would be a payback period associated with some of that energy recovery equipment. So there's a lot of decisions to make early in a project, depending on the owner's budget, depending on, the sophistication of the facility staff and maintaining that kind of piece of equipment, that can help mitigate some of that cost, that operating cost issue. But no matter what you do, it's going to be more energy. So again, it just kind of comes back to trade-offs and what's most important to you as a healthcare institution.
Energy consumption is one aspect of a building's efficiency, but one that's frequently in the limelight here in the Mountain West is actually water efficiency, water conservation. And so a lot of our hospital systems or hospital buildings in this area and really around the country use cooling towers as sort of the place where the heat is rejected from the building to the atmosphere. And so those rely on, again, evaporation, like I was talking about earlier. And so you're losing water. The more you have to cool, so maybe the more outside air you're bringing into a building, the more water you actually have to evaporate to make that cooling happen. Here in Colorado, especially in Denver, we're on the east side of the Continental Divide. We're in what's called a rain shadow desert. 80% of the population of Colorado lives in this desert on the east side of the Rockies, but 80% of the rain falls on the other side of the mountains. And so we have a pretty significant challenge to meet all of the Front Range corridors water needs throughout the course of the year. The more cooling you have, the more water you have to use. So water conservation is another area where 100% outside air systems can impact a building's efficiency.
Evan, earlier you'd mentioned specifically like operating rooms, surgery centers. Are there any other areas within a hospital that might benefit the most from 100% outside air systems?
Yeah, so obviously there are some spaces where there's a lot of really nasty stuff going on and they need to be exhausted. We can't be recirculating the air that passes through those spaces. Our laboratory spaces where whether it's research, diagnostic, A lot of those will want to be exhausted. So if you have a large sort of concentration of laboratory spaces, that would be an opportunity for a 100% outside air system. And then there are other systems that are not so much that we don't need to prevent air from recirculating from those spaces, but we want to protect what is in the space from being exposed to contaminants in other spaces. So these would include, operating rooms, protective environment rooms for patients with compromised immune systems. We don't always have to do 100% outside air systems for those spaces, but they tend to be a higher outside air percentage just to meet the code requirements and to avoid the kind of contamination that we don't want to get into those areas.
Yeah, and to add on to that too, Evan, when you think about a hospital particularly, and where the contaminants or pathogens would enter a hospital, the biggest place is through human beings, and where most human beings from the outside come in is, I think of an emergency department, where that's a place where if you're going to the emergency department, typically something's wrong. So the likelihood that somebody would walk in there who would be infected with something that could potentially spread to other areas of the hospital or to other patients within the emergency department, that, especially in the context of the pandemic, that was one that I personally worked on a number of projects to make those air handling units that serve air and filter air for an emergency department, to convert those to be able to be that, what I mentioned earlier, that pandemic mode type of operation, where we have a high concentration of COVID-19 patients in our emergency department. We want to be able to have that HVAC infrastructure to bring 100% outside air into that emergency department, so that, as the users, as the nurses and the doctors know, that whatever air is coming out of the ceiling grill is never been exposed to any other exam room or isolation room or trauma room within that ED, which is within that emergency department. So it's just another level of assurance or insurance for the actual hospital staff, that they know that they personally, the people who work at the hospital, and also the other patients, are as best protected as they could be from cross-contamination within a hospital. Because studies and research have shown that hospitals, although they are designed for patient care and to treat things, they're also the number one source of spreading diseases and infectious diseases particularly. So there's a higher risk of getting infected by something when you enter a hospital than if you go into a mall, for example. So that's one thing that I have noticed that hospitals can benefit from, is the emergency department.
Troy, you also just mentioned the maintenance part of it. Can any of you discuss the maintenance requirements for these systems compared to something more traditional in terms of like return air?
I would say it's more maintenance on your filter. It's 100% outside air you're getting, depending on where you're bringing air in. You could have a place near some type of plant where you've got something in the air. You have to replace those a lot. I know we haven't got into it much, but one of the downsides of 100% outside air is the smells. We had a project probably 15 years ago at a local hospital where they had a back of house area where they had 4 or 5 air handlers that they had the big outside air intake, and it was right near where they pumped their grease trap. And so once every, I think it was 3 weeks or once a month, the truck would come and all those smells would get into the intakes, and they would have issues all over those boards where those intakes were. And so we ended up doing carbon filtration, which is actually pretty cool when you start looking into it, because the things that they use, you would never even think that they use in their blends. Do these canisters. One of the things they use is coconut hair. I mean, I would have never known that has anything to do with mitigating smells, but based on the smell you want to remove, whether it's jet fuel or whatever it is, they've got different blends that they use.
Yeah.
In like a filter bank, and we have not had any issues since. It's been 15 years. I think they've replaced them maybe one time. So we have another project we're working on right now, where they moved their helicopter pad from off the hospital to the roof and didn't do a wind study. So there's some outside air intakes that aren't super, super close, that if you didn't really take a hard look at it, you wouldn't think it'd be an issue. But based on the wind direction and the time of year, they get some of that fuel smells in their intake, and it serves critical spaces. So we're looking at doing something similar or moving their intake, maybe ducting some things further away from that location. But I don't think enough people really look at, the locations for these things. There's companies that do wind studies specifically for this. It was really cool. This company, they make like a 1/20th or whatever scale model, like, and it's probably 1/100th. I don't know. It's really small. And they test it based on, hey, I'm going to put some smells over here and I'm going to do some testing. And they determine, yeah, you're going to need some pollution control units for your kitchen where, we weren't sure. The intake is 150 feet away, but based on prevailing winds and time of year, yeah, you could have issues. So we're doing pollution control units. So I don't think enough people look at the actual odor problem that can happen as a side effect of really high percentages of outside air.
Yeah, that's really fascinating. I'll expand on that to another question, which is in terms of patient comfort. So you mentioned smells. What about noise and temperature? Have you guys had any interaction with how air and outside air can affect noise and temperature for patient comfort, or any other stories about smells from you or Luke or Evan?
Well, I'll say that as long as we as the engineers are doing our job correctly, temperature and noise issues should be no greater in a 100% outside air system than in a recirculated air system. It comes down to the fact that we would have to have larger infrastructure, meaning like more cooling capacity, more heating capacity available to get, let's say, 95-degree air down to a level where, the interior space is within the normal parameters of patient comfort. So between 70 and 75 degrees. From a noise standpoint, you have fans either way. Maybe you have some larger fans if in a 100% outdoor air system, because you have some thicker heat exchanger and heat transfer devices in the airstream to cool that air down more. But as long as we as the engineers are analyzing those noise and temperature concerns and accounting for them in our design, it shouldn't have a negative impact on the patient.
I would like to piggyback some more on the odors issue, because this topic of 100% outside air is very much based on the idea that the outdoor air is going to be, for the most part, cleaner, fresher than it would be if you recirculated it. But that's often not the case here in the Mountain West because of all of our wildfire issues that we have to contend with. Obviously, some of that makes its way east from time to time as well. But it's very common out here. And so a few years back, we had the Marshall Fire between here in Denver and Boulder. It was destroyed a massive amount of private residences, like $2 billion in damage. The smoke damage alone forced a 3-week closure of one of the local hospitals. It wasn't affected by the flames at all, but it was just the smoke just suffocated the entire hospital. They had to close it. And so that's an extreme example, but wildfire smoke does travel a long way. So at a lot of the hospitals out here, you have to consider that. So those carbon filters that Troy was talking about are something to consider in high outdoor air percentage systems, or even just normal outdoor air percentage systems that do serve critical spaces like operating rooms. It's putting those in to prevent the smoke from a potential wildfire in the area from affecting the indoor environmental quality of the spaces.
There's just so much to consider that you're not thinking about, at least somebody like me is not thinking about. Are there any innovative technologies or approaches that you've all been exploring? And I kind of go back to what, Troy, you were just saying with some wind studies and things like that, that are enhancing the benefits of outside air while also mitigating some drawbacks?
A traditional HVAC system for a hospital involves using air to do all of the cooling and heating for a space. So pumping air into a room to cool it or to heat it. There are alternative systems that are being more widespread and particularly developed in Europe and then making their way over to North America, such as something called a chilled beam system, where instead of using air to do all of the heating and cooling for a room, there's actually kind of a room unit that has a water coil in it. So you're pumping water to this unit and a smaller amount of air to it, and then you would need for actually the whole cooling of the room. So water is a more energy dense compound than air is. Air is not a very good heat transfer medium. it's useful because, we're swimming in it. But if you're able to use a system like a chilled beam system, you're able to use smaller pipes to deliver water to a room, cold or hot water to a room, as opposed to a large duct to move air around, because water is also a lot easier to move around than air is. Air is a little bit tricky to, and a larger energy cost to move it around. So there are systems that are, I guess, relatively new, at least in some markets in the United States, that are specifically designed to be used with 100% outdoor air systems. And the design and the details of those could be a whole other episode, but just, I guess the big point is that there are some systems out there that are kind of trying to use outside air to its full potential.
The project we just got done with CDs and controls is a big part of energy, right? How we're controlling things. Is it, different engineers have different approaches and different opinions on what is the most energy efficient way. When's the best time to shut off a chiller? When's the best time to turn on another boiler? All those types of things. And we started getting into a little bit of talking with some of these newer controls companies that are going to start integrating AI into some of the algorithms on when is the decision made to do X, Y, or Z, and using historical data as well as trending data in the hospital it's being used in to find the most efficient way to have everything operate, at the least kW per ton possible. So they've got things like that now that aren't AI, like JCI has something it's a magic box that they don't tell anyone what it is, but it's chiller plant optimization stuff, which is happening. They sell it at a premium to owners, and we can do very similar things just with the control systems. But I think moving forward, AI is going to have a huge piece in the controls and may help save a significant amount of dollars.
You're kind of segueing perfectly into my final question. If anybody's listened, I'm a bit of a futurist. I like talking about what do you see happening and evolving with these ventilation strategies over the next 5 to 10 years. Troy, you just mentioned a really good one by looking at data and analytics and really trying to dive into that. You guys have any others that are kind of that you've been hearing about from your specialties?
I think one of the big things is there's a lot of great technology out there, but it really comes back to something that Troy mentioned earlier about the comfort level that the facilities staff at the hospitals that we work at, the comfort level that they have with these new systems. Because again, they're concerned about making sure that patients are comfortable and safe and healthy. And when something new comes along and they don't have maybe they don't have any buddies in the industry who've used this system and have had a good experience with it or something along those lines, then they're pretty hesitant to do that. And so part of our role, I think, as engineers is whatever the innovative strategy or piece of equipment, to do the necessary research, to gather references whenever we can, to help our facilities staff we work with to sort of be exposed to the pros and cons of these systems and just give them all the information they can have so that they can make decisions to embrace innovative technologies where they have an opportunity to improve, the energy efficiency of their hospital, serve their patients better. And so that's one of the challenges I think we have to overcome with really any innovative technology.
Last thing I would add to that is in terms of technologies that I think are quite interesting is looking back at the goal of 100% outside air, which is to mitigate indoor contaminants in the air. The sort of blanket approach would be to introduce 100% outside air all the time, make sure that there's no question that whatever air is going into that room is the least amount of contaminants that we can produce for that room. Caveats for wildfires and things, but let's just assume that the outside air is clean. Technology I think is quite interesting is doing sort of air sampling or testing the actual kind of contaminant levels in a room, or sort of the lagging indicators like CO2, which is what humans breathe out. So with CO2 we breathe out all sorts of other contaminants and things that are in our lungs and whatnot. So as opposed to just always 100% outside air, maybe there's some sort of a monitoring system in each patient room or something that as soon as a high concentration of something is detected, the control system would automatically introduce more outside air to sort of knock down that contaminant level So it's kind of a way of trying to have best of both worlds, where you're trying to maintain energy savings and be efficient and not be a big energy hog, but also the ultimate goal of maintaining patient care and comfort and safety.
I actually just walked out of a lunch and learned to do this, and we had a manufacturer that has a UV product where it's a small air device that has a little UV light in it, and it just recirculates air into space. I guess he had some case studies done at a nearby hospital, and they decreased pathogens or something by like 95%. I mean, I know it's in marketing stuff to us. Another thing, about 5 years ago, we had an electrical lunch and learn, and there was a vendor in here talking about, it wasn't a UV light, it was a different type of light, but it was a light that emits a wave that kills a lot of this thing as like pathogens and different things as well, but it doesn't hurt humans. I haven't heard much about it. It was all the hype at the time, but I haven't heard much about it. But I think as those things evolve, you may have a lot of lights in your hospital that are killing things. You could have UV lights that are killing things. So a lot of different things throughout the hospital that are working in conjunction with a well-designed system to try and just minimize risk in the hospital, different things, right?
Thank you all three for joining me on this episode.
Yeah, thanks, Brian.
Thanks again to Evan, Troy, and Luke for joining me on this episode of BSA by Design. You can connect with them on LinkedIn. If you're interested in learning more about BSA or our engineering services, we encourage you to visit our website at bsalifestructures.com. There is a link in the show notes to contact us for more information. Be sure to subscribe to BSA by Design on Apple Podcasts, Spotify, and YouTube Music so you don't miss an episode. And we've got more content and project stories to share on social media, so be sure to follow us on LinkedIn, YouTube, Facebook, Instagram, and X. That's going to do it for this episode. Join us again next time on BSA by Design.